Hello, another AQA A-level Physics multi-choice question on the mechanics topic. If you want to attempt the question yourself, pause the video now. If you got the answer B, well done. Keep watching if you want to see my explanation. So, a 0.2 kilogram mass is suspended from a spring. A 0.1 kilogram mass is suspended from the 0.2 kilogram mass using a thread of negligible mass. The system is in equilibrium, so nothing's moving, nothing's accelerating at the moment. And then the thread is cut. What is the upward acceleration on the 0.2 kilogram mass at the instant that the thread is cut? Well, if I'm going to find the acceleration of this mass, I'm going to ultimately use the equation where the force is equal to mass times acceleration. I'm going to say the resultant force because that's correct. If I rearrange it, I'll discover that the acceleration is equal to the resultant force over the mass. Well, we know the mass that's going to accelerate, it's this 0.2 kilogram mass. We need to find what the resultant force is on that mass at the time. So, first of all, we could find out before the string is cut, how much force is the spring producing? Well, it's in equilibrium, so the force produced by the spring must be equal to this total weight of the 0.2 and the 0.1 kilogram masses. So the total weight to start with, which is the force the spring has, is, we know weight is mass times gravitational field strength. So the total mass is 0.3 kilograms, gravitational field strength 9.81 newtons per kilogram, sorry. So the total force that the spring is producing is 2.94 newtons. Okay. When the spring is cut, there's still a downward force being produced by this second mass. So what's that weight of the second mass? The weight of the 0.2 kilogram mass is again mass times gravitational field strength. Its mass is 0.2 kilograms, gravitational field strength 9.81. We've got a force of 1.96 newtons. So the spring is producing a force of 2.94 newtons upwards. This weight is producing a force of 1.96 kilograms downwards. So if I find the difference between those two, I'll find the resultant force. So the resultant force is that force upwards by the spring, take away the force downwards by the mass. The weight of the mass is 0.945 newtons. So now I can come back to this equation. I can use 0.95 newtons for my resultant force. It's trying to accelerate a mass of 0.2 kilograms. I get an answer of 4.8 meters per second squared. Okay, well B 4.9, there may be a rounding error in there, so B is the correct answer. Now there is a quicker way of looking at this, and in multi-choice it's always good to find the quicker ways, and that is that we can think of that spring having to support all that weight to start with, the 0.2 and the 0.1, the weight produced by the 0.2 and the 0.1 kilogram masses. And when the string is cut, the weight that is the force that is released for the spring to do some acceleration is the force that it was producing to support that 0.1 kilogram mass, and you discover that it was about 0.95 newtons. Okay, I hope you found that useful. If you did, please press on that subscribe button for me. Thank you. Share with your friends, watch more of them in the series. Thank you for watching.